Hey, have you ever wondered what Azure private endpoints are? Or maybe you've tried to configure one, but you're not quite sure how to approach DNS? We'll find out on this MS Cloud Bros video. Hey, Jeremy Wallace here, Microsoft MVP, certified trainer and certified solutions architect expert for Azure. And today we're going to talk about Azure private endpoints, what they are, why you would use them, and how to configure them inside the Azure portal. But first, why don't you take a moment to like this video, subscribe to this channel, and hit that notification bell so you can stay up to date on all the great Microsoft Cloud content that we produce. All right, let's dive right in. Azure private endpoint, what is it? When we talk about Azure, there, of course, is a myriad of different services that you could utilize, but one of the primary ones that organizations do have is infrastructure as a service. Think about a virtual network that you spin up that has an IP address space associated with it. You carve up that IP address space into smaller subnets. You have virtual machines running Windows Server or Linux that have a network interface card that a private IP address is assigned to. Those virtual machines then communicate with one another through that virtual network over those private IP addresses. For instance, one server could communicate to reach a database that's running on another server, and all of that communication happens within inside that virtual network. Or you may have an on-premise environment, a local office network that has a site-to-site VPN connection or express route with Azure that you're able to reach resources that sit inside your virtual network, again, over that private IP address. And so none of the communication with those resources happen directly over the internet. They're all within these private networks. Now, the problem that is presented is for PaaS services that are outside in Azure. Things like Azure Storage, Azure SQL Database, Synapse Analytics Workspaces, Azure Web Apps. These services by nature, by default, do not have a direct connection to your virtual network. They are services that generally produce a public endpoint. For instance, Azure Storage, when it's created, the endpoint given to you is a publicly accessible one. So you can use that Azure Storage anywhere over the internet. There is no direct private communication with that storage service through your virtual network. You have to create that, and that is done with a private endpoint. For instance, if we take a look in the Azure portal inside my lab environment here, we have this ST Storage Test WS201 account. Now, haven't done any additional configuration with the storage account. The only thing that may be different from one that you spun up is I chose to do the Provision V2 model. I directly built the storage for Azure files as the intended purpose of it. So you may spin up a general V2 one, or you may use a premium Azure file solution. But this one specifically is the Provision V2 for Azure files. And if we look at endpoints, we can see for file service, I get this ST Storage Test WS201.file.core.windows.net. Now, again, if you spin up a different, like the general V2 Azure storage type, you may see blob service in here, table, etc. You may have other endpoint options. Again, I provisioned the one specifically for files, so that's the only endpoint that I'm given. Now, if I look up this endpoint for domain name resolution, so if I do ns lookup st storage test ws201.file.core.windows.net, we can see that it resolves to a public IP address. Not only that, but we also see that this name that I'm looking up, this endpoint that I'm given, is actually just an alias, and that the actual original record here that we see is this file.mwh23prdstr01c.store.core.windows.net. So when you are provisioning storage, the actual endpoint is randomized in the back end, and you are given a friendly alias, the name of the storage account, to work with it. And that points to a public IP address. And so if we begin using the storage account, for instance, if I were to access that storage account from a server inside my Azure environment, when it goes to reach out to this location, of course, it's going to do a DNS resolution, and it's going to resolve that to a public IP address. And so then this server is going to reach out over the internet to interact with the storage, even though that this server lives in Azure itself and the storage account lives in Azure itself. Communication between the two is going to happen over a public endpoint, not a private one. And so that is where private endpoints come in. So if we stick a private endpoint for this service, what's going on is a network interface will be provisioned as part of this private endpoint specifically for the service. That private endpoint will be assigned a private IP address that's directly on my virtual network. And what we need it to do is we need this name to be resolved to a private IP address, not a public IP address. So let me show you how this works. So if we go back to the Azure portal and we go to the networking tab, I'm going to create a private endpoint for this storage account. So I'll use the same resource group that my storage account is in, and then I'm going to need to name the private endpoint. So I'm just going to name it PE for private endpoint, storage test 02. And then for my network interface name, I'm going to start that with NIC. So private endpoint, network interface card, West US 2. And if you, again, have a different storage account type, you may have different options for a target sub-resource. So if you're using that general V2 storage, you'll see blob service there as an option. This, I'm going to provision the private endpoint only for this existing option here, which is file. Then the virtual network. So this is the virtual network where my virtual machines are sitting on. So I'm going to drop it in that same subnet. And I can choose to either dynamically allocate the IP address, but that private IP that gets assigned to the network interface card is going to be assigned dynamically to it, or I can statically allocate that IP address. For this video, I'm just going to dynamically allocate it. And so we see here private DNS integration. So I get a lot of questions from people when they get to this part of the private endpoint. A lot of people will try to spin up the private endpoint themselves, and they'll get to this and what am I supposed to do? So private DNS integration spins up something called a private DNS zone. So if we go back to my Azure diagram here and we take a look at this process in which a virtual machine needs to do DNS resolution of the storage account name, there's really two options depending on what you have configured inside Azure. And the two options, if we head over to a virtual network here and head down to DNS servers, and this can be configured directly on a network interface card, or you can configure it on the virtual network. And the two options are default Azure provided DNS, or you can set custom DNS servers. Now, a lot of organizations are going to select the custom DNS, particularly if they have Active Directory or Entra domain services. And if they have resources joined to those domains, they're typically going to use their domain controllers or the Entra DS IP addresses for the DNS resolution. Now, if you use the default Azure provided DNS, what's going on there is virtual machines inside Azure can communicate with something called a wire server through this IP address, this 168.63.129.16. Now, this is a public IP address. It exists in the public IP space, but Microsoft owns this and they only make it available inside of Azure for this specific purpose. And Azure virtual machines can communicate with this wire server for various things, such as the VM agent itself can communicate to Azure that a virtual machine has successfully turned on, or it can reach out to the service for things like DNS resolution. And so when the server reaches out to that, it has access to a filtered DNS service that's invisible in the background. We don't have access to these virtual DNS servers that are in the back. However, we can create private DNS zones. And what private DNS zones allows us to do is create records inside it for DNS resolution. And so when we create a private endpoint and we have it create a private DNS zone, what it'll do is create a host record, an A record, inside that private DNS zone that says, hey, for this storage account, resolve, does this with that host record, A record, to this private IP address. And so when a server goes, hey, I need to talk to this storage account, it reaches out for DNS resolution. It resolves that to this private IP using that private DNS zone. And that resolved IP, if we indicate that with a response from DNS that says, hey, private IP address of the storage account is X, then that server can then communicate with that storage account over that private IP address that's assigned to that NIC. Now, private DNS zones, they can be connected to multiple virtual networks. There is a way to link them. And this is an approach. You could, even if you're using custom DNS servers, set this as a secondary or tertiary DNS server for resolution. So if you want to take that approach, it is possible. This DNS service, however, this wire server IP address, it can't be communicated with outside of Azure. So if you have an on-premise Office local LAN network where you have domain joined servers and you try to use this IP address, that exists outside of Azure. So it's not going to be able to resolve these private DNS zones. Now, Microsoft has provided a way for that to be possible through another product, but we're not going to talk about that at this moment. We can go ahead and create this record. It doesn't hurt anything when we're setting up our private IP, so that if we do have anything that sits inside Azure, inside that VNet, it can resolve against that. But again, in our actual environment that are using custom DNS servers, we need to create a way for those custom DNS servers to resolve that private IP address for that name. And we'll show how to do that here in just a moment. So I'm going to go ahead and let it create that private zone. So we'll let that create the private endpoint, and then we'll configure DNS resolution for it. All right, so I'm in my provisioned private endpoint. And so we can see some information here, such as the network interface that we had created for this private endpoint, and then the private link resource that's attached to it. So we can see that this storage account is connected through this private endpoint to the network interface. And we can see the virtual network and the subnet that it's sitting on. Now, if we take a look at the DNS configuration here, we can actually see the private IP address that's assigned to the NIC. And we again see that fully qualified domain name. It hasn't changed. That's the same endpoint for the file service that we were presented with earlier. And down here at the bottom, we will see that private link.file.core.windows.net, that private DNS zone that was created for this service. And if we look in here, we can see an A record, a host record created for this 10.123.1.9, the private IP address that's assigned to that NIC. Now, if we look up in this corner, this private DNS zone is specifically for private link.file.core.windows.net. Now, that's slightly different, if you recall, than this address here, .file.core.windows.net. It has that private link. And we'll address that here in just a moment. I'm now going to head over to a virtual machine that sits inside that virtual network. And let's try to resolve that name. So if I go to my private endpoint, grab that endpoint, and from this virtual machine, let's look up. what do we get? We see, again, that name is an alias, and it points to this public IP address. So we're still getting a public IP, not private IP address that we were hoping to resolve to. But now we do see the addition of another alias, this st-storage test ws201.privatelink.file.core.windows.net. Now, we were just taking a look at that private DNS zone was created for this space. And we'll see how those two can connect here in just a moment. This virtual machine actually happens to be the domain controller. So what I'm going to do is I'm going to set up a forward lookup zone from the server, and we're going to create it for this private link.file.core.windows.net. So let me copy that. So let's go new zone. So I'm right clicking forward lookup zone. I'm creating a new zone. It's a primary zone. I want to store the zone in Active Directory so that it's available across all of my domain controllers. Now, this process is the same. If you're using Entra Domain Services, same process. Select how you want this zone data replicated to all DNS servers running on domain controllers in this domain. My zone name, I'm going to use that private link.file.core.windows.net. And I'm going to go with the recommended for that and finish. So when I'm done here, I see private link.file.core.windows.net under my forward lookup zones. So we have a blank slate in here. What we want to do now is create a host record, just like we saw in that private DNS zone. And again, we'll talk about that in just a moment. But what I want to create here is a new host record, an A record, and I want to point it at this storage account name. So this is the name of my storage account. So that's the name I want to use here. And you see if we plug that name in, my fully qualified domain name ends up being this whole alias down here. I need to grab my private IP address. I'm going to head back to that page, grab the private IP, and 123.1.9. Okay. Now if I add that, when we take a look, we now have an A record for this storage account name pointing to 10.123.1.9 under my private link.file.core.windows.net forward lookup zone in DNS. Now, if I do a resolution of that name, we'll see it resolves to the private IP address. Now, as you can see, the name we're looking up is still that file.core.windows.net. So how in the world is it resolving from this name to this private link.file.core.windows.net in order to get me that private IP address? Wouldn't you think we would want to create a forward lookup zone that was for file.core.windows.net and create the A record there? The problem is if you created a forward lookup zone for file.core.windows.net, there are other services that are using that namespace. You would then be on the hook for creating every single DNS record for anything that you wanted to get to in Azure that was using that namespace. So what private link, this other private link namespace does is allow us to be able to create these private records without affecting the public namespace and our resolution of it. Now, how it's going about doing this is when we do a domain name resolution. Let's take a look at our diagram. Let me get rid of all of these arrows here just to avoid confusion. Now, when we do domain name resolution, my servers are reaching out to my domain controllers for that DNS resolution. The domain controller is looking if that namespace exists inside its configured DNS in those forward lookup zones. Now, obviously, this namespace is not in there. It does not have a forward lookup zone for file.core.windows.net. So what does it do? It forwards that, and ultimately this depends on if you have it configured in your Active Directory environment to do this for your DNS, but this is generally the case, is your domain controller, if it can't resolve it, it's going to forward that resolution out to public DNS. In my particular case, if we take a look at the DNS service here and go to properties, and I go to forwarders, we can see that it's set to go out to Google's DNS service, 8888, if it's unable to resolve something in here. So can't resolve, there's not a namespace for it to resolve here, then it forwards that on to the public DNS service there. So that name resolution goes out to the public DNS service, and the public DNS, as we saw before, if we take a look on my machine, it is able to resolve this alias to a public IP address. But now, since we created that private endpoint, as we saw on the domain controller, it's responding, that public DNS is responding with this other alias. It sees that there is now a private link.file.core.windows.net alias, and that alias is weighted. So we go back to my diagram here, it's saying, hey, I can resolve this, but there's an additional alias now, and this alias is weighted. It means it takes priority for resolution. You want to resolve this. So this is being responded to your DNS server, so my domain controller, and now it is on my domain controller to resolve this private link.file.core.windows.net name. And so it, just as it did with the first process, it's going to look, hey, do I have a private link.file.core.windows.net forward lookup zone inside my DNS? And thanks to our configuration, it does. And so it's going to look inside that forward lookup zone for that host record or any type of record that we have in there, but particularly in this case, that host record. It sees that name, it resolves to a private IP address, and so the domain controller goes, yeah, I can resolve that name. It's this private IP address, and it offers that private IP address up to the server. In which case, this is now 9. So it's offering, so it resolved that private link name to this .9 IP address, gave that to the server. The server goes, okay, I'm going to connect to that when using this name. So ultimately it resolved this file.core.windows.net to this private link one, which resolved to that private IP address. And now that server reaches out to the private IP address and is able to get to that storage account through that private endpoint. Now the same thing happens on the private DNS zone side. So if I'm using the wire server for my DNS resolution, it's going to see if it can resolve this file.core.windows.net. If it can't, it'll reach out, it'll resolve publicly to find that private link.file.core alias, and it's up to the DNS server service inside Azure to resolve that private link.file.core.windows.net space, and it can because it has a private DNS zone, and inside that private DNS zone is that storage account name, and that resolves to that private IP address, and again it offers that resolved IP address to the server. The server is then able to communicate to the storage account through that private IP address. That's a lot of arrows everywhere. Now, another thing we can do is we could set that to include that 168.63.129.16 address. And so if you choose to do that, you could add that in here. So that name resolution if it can't be resolved in Active Directory, goes out to the wire server to tag Azure DNS service to look for those private DNS zones and resolve. And in that method, you wouldn't have to create a private link.file.core.windows.net forward lookup zone in your Active Directory. That request would just get forwarded out after the domain controller realized, or the DNS service on the domain controller realized it can't resolve that domain space. Now, again, downside of that is if you have Active Directory that stretches across on-premise and Azure environments, those on-premise ones aren't going to be able to forward to that IP address that's only available for Azure VMs. I just wanted to note that it is a possible configuration, but it has downsides. My recommendation is if you're using Active Directory for DNS resolution, put that forward lookup zone inside DNS. If you're using Enter Domain Service for your DNS resolution, put that forward lookup zone inside Enter DS. However, if you're just using native Azure DNS service, use those Azure private DNS zones for that resolution. Now, last thing I want to mention about private endpoints is not only does that allow your resources an ability for it to interact with those services through your private network, but it does allow those services, in some cases, for instance, if we had a Synapse Analytics workspace, it would allow that Synapse workspace to be able to get to resources that are on your VNet. So it works both ways. Sometimes it's a matter of allowing your resources on network or on premise to be able to access those Azure resources through that private network, or allowing those services to be able to access other resources that are within those VNets as well. As you use private endpoints, also keep in mind that now that private IP address is subject to your networking rules. So communication with it is going to be affected by user-defined network routes. So if you're using route tables inside your environment, that's going to affect its access. Network security groups that protect those subnets are also going to determine access for those private endpoints as well. So think about all of those things as you work with private endpoints. How's my DNS resolution occurring? Can my resources communicate to that private IP through any NSGs? Is my route tables causing any issues accessing that private IP address as well? And all of those things come into play, both when trying to communicate to the resource or allowing that resource to communicate to your other resources through that private endpoint.